In this video tutorial, we will use MindFusion Java Profiler tool called HyperDebug to discover a memory leak from a Java program. The program has a main class called Employee Selector, which registers 10 employees in a global map instance. The employee class is a simple, standard one. We shuffle the employees and get a random one to be the winner. We run the program and see that it logs the number of the employees to be 20, twice as much as the number of registered employees. So, where's the problem? We go to the MindFusion website and navigate to HyperDebug. We download the archive and unzip it. Inside is an executable jar file, and we run it. The profiler starts with the config window. We navigate to the class file of our Java application and select it. We tick Trace Parameters to collect data about the method parameters. There are plenty of other options, but we will only tick Don't Show Package Names, which will only log the method names without the package prefix. Then we hit Run. The program executes, and here is the collected data. As expected, we see that register employee is called 20 times rather than 10. The other methods look okay. If we go to time monitor, we can see that no method gets abnormal amount of execution time. Method data shows us that register employee really leads in method calls, but it's the call graph step that can tell us exactly where register employee was called. We see that it was called once from register employees and then from shuffle employees. Let's look at these methods. Register employees looks like a rather neat method. In a cycle that iterates as many times as the provided parameter, a new employee instance is selected, and register employee is called to add it to the global map instance registry. Let's look at shuffle employees. We get all employees, then we shuffle them, and then we clear the map. Let's look at the call tree for the method. Yes, register employee is called 10 times in the shuffle method. Get employees just gets all values from the map and returns them as list. The collection is then shuffled and the employees are removed from the map. Now that's interesting. First, it makes the impression that we cycle through a collection that changes its size meanwhile. That's a mistake, and we will correct it by storing the size of the map in a variable before we start the cycle. Then we remove entries from the map. The interesting part with the remove method that we remove an item by searching for it with a new instance of the identifier class. Now, if we look at the identifier class, we see that it only has a get method and a constructor. This means that since object instances in Java are passed by reference, we actually search to remove an employee associated with a brand new identifier instance. Though the two identifiers have the same ID values, they are different objects, and Java could not match the new identifier with any employees that have it, because the employee in question uses another identifier instance. Therefore, nothing is removed from the map collection. The fix is to implement the equals and hashcode methods that are responsible for comparing two instances of the same class. Now, if we run the program once again, the count of employees is correct. And this is the end of the tutorial. Thank you for watching, and thank you for your interest in MindFusion Developers Tools.